Hi dear students, welcome to Bosco Campus Vision. This is Seema Dudley. Welcome to my another video on the topic Internet of Things. In this video, we will be discussing about the transport layer. The transport layer offers peer-to-peer and end-to-end connection between two processes on a remote host. The transport layer takes data from the upper layer and then it breaks into smaller size segments. Then it hands over to the lower layer for the delivery. And we can see some of the functions of the transport layer as this is the first layer which breaks the information into smaller segments, and another function is this layer ensures that data must be received in the same sequence in which it is sent. And another function is this layer provides end-to-end delivery of data between hosts which may or may not belong to the same subnet. And another function we can say is all server processes intend to communicate over the network are equipped with well-known transport service access points and also known as port numbers. That is TSAP, that is Transport Service Access Points. Then we can say the two main components of transport layer are transmission control protocol and user datagram protocol. അപ്പോൾ ഈ ട്രാൻസ്പോർട്ട് ലെയറിന് ഉള്ള ടു മെയിൻ പ്രോട്ടോകോൾസ് എന്ന് പറയുന്നത് TCP and UDP. TCP means Transmission Control Protocol and UDP means User Datagram Protocol. So we can check what is TCP. TCP provides reliable communication between two hosts. രണ്ട് ഹോസ്റ്റുകൾ തമ്മിൽ റിലയബിൾ കമ്മ്യൂണിക്കേഷൻ നടത്തുന്നതിന് വേണ്ടിയിട്ടാണ് നമ്മൾ കോമൺലി നമ്മൾ TCP യൂസ് ചെയ്യുക. ആൻഡ് വി ക്യാൻ സേ കോമൺ ആയിട്ട് രണ്ട് മൂന്ന് ഫീച്ചേഴ്സ് ഓഫ് TCP പറയുകയാണെന്നുണ്ടെങ്കിൽ this transmission control protocol is one of the most important protocol of Internet Protocol suite. And it is most commonly used protocol for data transmission in communication networks. And we can see that this TCP is a reliable protocol and it provides error checking and recovery mechanisms, and also it provides quality of service, and also it provides end-to-end communication. And the second protocol is the user datagram protocol, that is UDP. And this UDP provides an unreliable communication between the two hosts. And with this connectionless protocol, data can be quickly sent between source and destination. But one disadvantage is there is no guarantee of delivery. നമ്മുടെ ഡെസ്റ്റിനേഷനിൽ ഡേറ്റ സെൻഡ് ചെയ്തു അല്ലെങ്കിൽ ഡേറ്റ റിസീവ് ചെയ്തു എന്നുള്ളതിന് ഒരു കൺഫർമേഷൻ നമുക്ക് എടുക്കാനായിട്ട് സാധിക്കില്ല. Next is about a new application protocol, that is Iot Application Protocol. When we start connecting all the smart devices to the network, we need a specifically designed protocol, that is Constrained Application Protocol, that is COAP, and it almost always uses UDP. And COAP is a simple protocol with low overhead, specifically designed for constrained devices. That is, when we are using this as smart objects, we need some kind of microcontrollers. And we know that now we are not using these smart objects in the network. So when we are adding these smart objects to the network, we need some kind of optimization and adoption. Okay, അപ്പോൾ ആ ഒരു optimization and adoption ഒരു simple example ആണ് the device language message specification or companion specification for energy metering application layer protocol, a popular protocol for reading smart meters in the utility spaces in Europe. യൂറോപ്പിലുള്ള സ്മാർട്ട് മീറ്റേഴ്സ് റീഡ് ചെയ്യുന്നതിന് വേണ്ടിയിട്ട് യൂസ് ചെയ്യുന്ന ഒരു പ്രോട്ടോക്കോളാണിത്. ഇഫ് വി ആർ യൂസിങ് ഇറ്റ് വിത്ത് IoT, we have to optimize these protocol. ഇപ്പോൾ നമ്മൾ സ്മാർട്ട് ഒബ്ജക്ട്സ് യൂസ് ചെയ്യുന്ന സമയത്ത് നമ്മൾ ഇപ്പോൾ കറണ്ടായിട്ട് യൂസ് ചെയ്തുകൊണ്ടിരിക്കുന്ന പ്രോട്ടോകോൾസിൽ ചില ഒപ്റ്റിമൈസേഷൻ ആൻഡ് അഡോപ്ഷൻ ആവശ്യമായിട്ട് വരും. Now we can compare the two standard or the global protocols for transferring data from source to destination, that is the device language message specification or companion specification for energy metering and LLN. LLN means low power and lossy networks. So when we are taking in account these two global standards, we have to consider certain things. First one is select TCP for cellular networks because these networks are typically more robust and can handle the overhead. For LLN, where both the devices and network itself are usually constrained. So UDP will be the better choice and often it will be mandatory. And the second thing we have to consider when we are transferring the data from source to destination is this DLMS or the COSM can reduce the overhead associated with session establishment by offering a long association over LLN. Long association means that the sessions stay up once in place because the communication overhead necessary to keep a session established is much less than is involved in opening and closing many separate sessions over the same time period. So for cellular networks, a short association better controls the cost by tearing down the open association after transmitting. And the third thing we have to consider when transferring data from source to destination is when transferring large amount of DLMS and COSM data, cellular links are preferred to optimize each open association. Smaller amounts of data can be handled efficiently over LLN because packet loss ratios are generally higher on LLN than on cellular networks. Keeping the data transmission amounts small over LLN limits the retransmission of large number of bytes may occur. Here is the assignment question. Explain the two main protocols that are specified for the transport layer.